welcome to my talk here about how to build a typical Spring Cloud architecture application. And all the code you will see in this session is available on my GitHub account. I will send you in the chat, and it's also on my slide, those accounts or repositories. And feel free to ask questions via the chat functionality. I will answer them after the session. So I think around 10 minutes before the end of the session, we will do a Q&A, and feel free to ask questions. So what's on the agenda for today? So first of all, I will briefly introduce myself, and afterwards I will show you how a microservice application benefits from Spring Cloud and how to build it. And finally, I will show you how to build a Spring Cloud architecture application on Kubernetes. So yeah, my name is Timo Salm. I'm a senior specialist solution engineer for the VMware Tensor portfolio, and joined VMware last year as a result of the Pivotal acquisition. And so in my current role, based on the description, I'm a thought leader in the field of cloud-native application development, and have a strong opinion on how a large enterprise should build, run, and manage modern applications. So the portfolio is really focused on modern infrastructure based on Kubernetes and modern applications, for example, with the Spring. And before my time at VMware and Pivotal, I worked as an IT consultant for more than 7 years. With the acquisition of Pivotal, VMware is now the vendor of Spring, and Spring plays a very important role in the Tensor portfolio. And Spring, as you maybe know, is the most popular Java framework with about 80 million downloads per month from Maven Central. And the goal of Spring is to simplify and accelerate application development. And due to its auto configuration, Spring Boot is the foundation for fast development of production-ready applications. And Spring Cloud supports the development of microservice architectures by implementing proven patterns, for example, for resilience, reliability, and coordination. Another project you are maybe not that familiar with is Spring Cloud Dataflow. Spring Cloud Dataflow can be classified in the direction of a function as service and enables the building and execution of stream and batch processing pipelines based on Spring Cloud Stream and Batch. On this slide here, we see a typical microservice application for a supply chain. And in the center of the slide, we have 3 microservices I implemented using Spring Boot and initially created on start.spring.io. The place where you should start with new applications, because it's really easy to get a basic project with all the libraries you need for your applications. The product microservice here is that you can see in the top. On the top only has one REST endpoint to fetch the list of products, and products are configurable via configuration properties. With the order service REST API, clients are able to fetch the current orders that are stored in the MySQL database, and they are also able to create new orders. And the product ID for a new order is validated with a list of products that will be fetched from the product service via a synchronous REST call. And after the order is created and stored in the database, information like the shipping address will be sent to the shipping service via asynchronous messaging. And after a configurable amount of time, that's for example 10 seconds, a status update for the delivery will be sent back via asynchronous messaging to be consumed by the orders microservice. And now let's find out what challenges a basic implementation like this for a microservice application has, and how Spring Cloud helps you mitigate these. The first challenge is that on modern platforms or in the cloud, the IP addresses of microservice are not fixed, and they will change over time. And so we need a component where all of our microservice instances register their addresses. And Other microservices are able to fetch that information based on, for example, a name of the microservice to be able to communicate via, for example, REST. And Spring Cloud's registry interface solves this problem using popular service registry implementations such as, for example, HashiCorp Console, Zookeeper, or Eureka, which we'll use in this example here. And also provides client-side libraries for the mentioned service registry implementations plus Kubernetes. So, and this is, we will see that later, so that also the client-side library for Kubernetes and how it works. And now in the code, I will show you how easy it is to connect your microservice to a Eureka registry instance and then use it by another microservice to connect to that microservice. Okay, so let's switch to the code. And as you can see, I have a main project with 3 sub-projects, my microservices here. And now we'll go to the order service. So that service where customers are able to create orders. The orders will be validated via the product list. And then the order will be sent to the shipping service. So what we have to do to add that service registry client and the registration is we first have to add a dependency. And in this case, the dependency is the Spring Framework Cloud or Spring Cloud Starter Netflix Eureka client. Spring Cloud. Hopefully. And we have to refresh Maven. And the last thing we have to do here is go to our application and add an annotation for the service discovery, and it's called enable discovery client. And with that, the microservice will register with that Eureka server and also is able to fetch the information of other microservices. And if we don't have an auto configuration of our services, for example, via specific end variables, if our platform, like for example, a Cloud Foundry provides this functionality, we have to define that IP of the Eureka service. So go to the application YAML, and then we can add that via the Eureka instance IP address. And that's it. After that, our service discovery works. And as I mentioned, so the our order service is fetching the products from the product service via REST API. And to use that service discovery, so that I don't have to specify an IP, I just have to put the name as an domain name for it. So in this case, for this product API URL, it's then HTTP as the product service, and the API endpoint is API v1 products. So that is, and as you can see, instead of an IP, we now because of the service registry, we're now able to target that microservice via that Spring name of that Spring application name of that product microservice. And with adding one dependency, that annotation, we are able to use the server discovery functionality. So it's really easy, as with all other functionalities I will show you here. Okay, let's now have a look at the next challenge we want to solve. And in this case, for the REST call from the order service to the product service, the order service is now able to get the addresses, as we know, of multiple product service instances if there is a need for that due to, for example, high pressure, that you have multiple instances. And we have a Spring Cloud Load Balancer as a library, and it's also an implementation now as a client load balancer that helps to spread requests across multiple service instances. And yeah, it's also really easy to add that to our application. So we can now go back to the code here and have to add the dependency for it. In this case, it's a Spring Cloud Starter Load Balancer. And as you can see here in my application, I have a REST template here that will be provided as a bean to my implementation. And what I have to do to enable that load balancing is that I just have to add a load balance annotation here. And with that, the requests will be spread across those instances that are of the product service that are registered at the Eureka instance. And in this case, if I do it like that right now, or currently, it's still the case that for that load balancer implementation, Ribbon is used. Ribbon is a Netflix project, which will no longer or further developed. So it's on maintenance mode. And because of that, we want to disable it and use that implementation of Spring Cloud Load Balancer that's embedded. So it has its own implementation, and we can do that with a Spring Cloud Load Balancer. Load Balancer enable Ribbon enabled. What is it? So okay, the problem here is normally it should be I thought it's Ribbon enabled or disabled, but it looks like I have just to enable it with the true now because of some changes. But yeah, hopefully then it will use the Spring Cloud Load Balancer. So as a summary, the default was that Ribbon is used, and I think that's still the case. Netflix project, but Spring Cloud Load Balancer also has its own implementation. And that's it. So it's really like adding the dependency, adding an annotation. And if you want to have a specific implementation of the load balancer, you can configure that. But yeah, that's it. Then you have a load balancing functionality, cloned load balancing functionality in your microservice. So it's really easy to configure and really great feature here. Okay, so now that we have added the client load balancing for the call from the order microservice to the product microservice instances to spread requests, let's try to improve the overall performance of remote calls via distributed caching. And for that, we will add the caching functionality here to the REST call and also to the JDBC call to the database. And with a Spring Boot's auto configuration and caching abstraction. And in this case, we're using Redis for that. So Spring Data Redis. It's very easy to add caching to the order service. And just for your information, we also have a caching solution available that's also compatible with the Redis API. It's called VMware Tanzu Gemfire, just for your information. But yeah, in this case, we're using Redis because it's more widely used than our Gemfire, and because of that, I built the example on that here. And to add that caching, let's go back to our code. First of all, we have to add the dependencies. In this case, Spring Boot starter cache. Spring Boot starter data Redis. And that's it regarding the dependencies. And now for sure we have to define the caching for our calls to the database and to the REST service. And the first thing is that we have to enable it for the overall application with enable caching annotation. And what you would normally do is go to the application YAML and define the host of the Redis database with the Spring Redis host. So sure that a microservice is able to connect to Redis. And what we do next is we have to define, as I already mentioned, what will be cached. And for the caching, our objects we want to cache, they have to implement serializable, and this is what we do right now. So just go to our object we want to cache and implement serializable. Okay. So normally you would add also serializable ID, but it works without two. So let's not spend too much time on stuff like that. Serializable. And as you maybe know, you can also define that or configure that in IntelliJ, for example, that it will be automatically generated for you. Okay, and so if we now have our object serializable, we can go to the product service, because that's the service from which the order service fetches the product. What we have to do here is add to the fetch products add the cacheable annotation. Cacheable. And give the cache a name. In this case, let's call it products. And that's it. So now if we recall the products, the first time they will be cached in Redis. And for example, if our service the product service is not reachable, not available, and also for a specific time to have faster calls, Redis will be used to get those information. So that's really neat. And now we'll also do the same for the database. That's the order service, and the order repository in this case, because we save the information in the database. And as you can see here, what's special, it's an interface. So how can we add those annotations? So what we have to do is we have to override those methods that are defined in the interface for the methods we use, and override it there. And we can see which of those we use if we go to the order application service here. And there you can see that we use the repository, we use the save functionality, the find by ID, and the find all. And so we go to the repository and override them, save by ID and find all. And for the find by ID, we just have to add the cacheable annotation, cacheable, and in this case it's just order, the name of the cache. Here the same with another cache name, orders. And the question now is, okay, what do we have to do at the save method? Because if we do that, the data changes in the database. So yeah, Redis is not aware of changes there. So yeah, we have to do something with our cache. And in this case, we have, or what I do here is I delete the cache for the orders. And this can be done via the cache evict annotation. And the first thing you have to define here are the cache names you want to delete. And in this case, it's the order and orders. And if, for example, you, because you only save one object here, you can, or you are able with that annotation to define that only specific entries will be deleted in the cache. But in this case, yeah, just that it's more easy, I will just remove all entries for the of that cache here if something new is saved in it. Yeah. And with that, yeah, we have added caching to our database for our database call and the REST call, and yeah, increase the overall resilience and also the performance, especially for the database call. Okay, well. Okay, so now it's time for the next challenge. And yeah, in a distributed system like microservices, requests my timeout or fail completely. And if, for example, the cache of the product list for our order service has expired and a request to the product service to fetch the product list fails, with a so-called circuit breaker, we are then able to define a fallback that will be called for all further calls to the product service until a variable amount of time to allow the product service to recover and prevent a network or service failure from cascading to other services. And Spring Cloud Circuit Breaker supports 3 popular open source options. And I will now show how to integrate resilience for J in the order service. So first of all, as with any feature I show you here, I have to add the dependency. In this case, it's Spring Cloud Starter Circuit Breaker Resilience for J. We have to refresh Maven, and now we go to the product service because yeah, there I want to implement that circuit breaker. So if a call to the product service, for example, times out, all other calls to the product service from the order service for a specific amount of time will not be sent to the product service, and instead I will implement the fallback. And with that, maybe, or in base case, the product service is able to come back and will not be, let's say, penetrated with requests. And yeah, that's a big problem. Sometimes if you have problems in a service due to performance and the number of requests, that if the service is in trouble and gets further a lot of requests, then yeah, he maybe will never come back. So in the product service, what I have to do first is to inject the circuit breaker factory here. Okay. And then we have to implement the logic for the circuit breaker. And as you can see here, I have my REST template call. And what I have to do is I have to wrap it in a circuit breaker create method. And so circuit breaker create. That's just the name of the circuit breaker. I'm adding and then there's that run functionality, and as you can see, there's first I have to supply a lambda of the run implementation and lambda function, and then I have to define the fallback. In this case, yeah, the run functionality is here. And then I have to define the fallback. So for the run, it's just the call to the REST service, and for the callback, a fallback, I will just do a log. So log error, yeah. Call to product service failed. And then I will return my fallback. And in this case, for example, just let's return an empty list here. I think there's some problem with yeah, maybe there's I missed something, but yeah, it should normally work like that. So yeah, it's also really easy to integrate the circuit breaker, as you can see, just at the dependency at the factory, and then with a create method and run, you have that you wrap that default functionality, and then you have a fallback. No, so relatively easy, and yeah, all the functionality is baked into the library. So yeah, that's also really great and helps you build yeah, the robust microservices. Yeah, let's have a look at the next challenge here. So yeah, As you know, apps sometimes store configs, for example, as constants in the code. So that's a bad practice and a violation of the popular 12-factor application methodology, and which requires a stricter separation of configuration from code. And the reason for that is that configuration can be significantly different across environments, but the code should be the same. And Spring Cloud Config provides server-side and client-side support for externalized configuration in a distributed system. And with the config server, you have a central place to manage external properties for applications across all environments. And let's see how to configure our microservice to use a Spring Cloud Config service instance. And it's, as for example, with a service registry, it's really easy to do that. It's just adding that one dependency and one configuration, and then we have that support. And you have your for sure you need your config server and configure it via, for example, a Git repository where all the configuration is stored. But for the microservice itself, it's really easy because it's just the Spring Cloud Starter config you have to add here. Spring Cloud Starter config. To refresh it, go to the application YAML, and there then you have to, based on the platform you're using, you have to manually add the URL to that config server. But yeah, we will see that later. There are some platforms that will do that automatically and check those configurations. Okay, next challenge. And with so many APIs in a Microservice application, developers, they need, or there is a need for an API gateway. One benefit of the gateway we're talking here about is that developers can control that gateway. So it's not like that enterprise API gateways where you have to create tickets to get your routes configured. And Spring Cloud Gateway really aims to provide a simple and effective way to route to APIs, and also provides a lot of features, for example, also that circuit breaker, load balancing, security features like OAuth and all that stuff, resilience. And let's now see how to create a gateway like that. And the Spring Cloud Gateway is open source, so it's for free. It's a library to build API gateways with a lot of filters, the functionalities you can use. We also have a commercial version of that that, for example, supports Client Foundry, and also one for Kubernetes with even more features and possibilities. But we will now use the open source one version, and it's really easy to get started or to add that gateway, because what we here have is started spring.io. As I mentioned, that should be the starting point. If you create a new project, you can define whether you want to use Maven or Gradle, Java, or other languages like Kotlin, the Spring Boot version you want to use. In this case here, we use the latest stable version, and also packaging the Java version. And then here on the right, you can add the dependencies you want to use in your service. And so let's first rename it here to Gateway, because we want to have Gateway application, and add the actuators. That's also something you should add to any project, because it's a lot of functionality to see whether your application is running. and also some other libraries need this support there. And yeah, so first thing, the actuators. Then we need Spring Cloud starter security, Spring Cloud starter config, because we added that config server functionality for the auto service config. Okay, and also the service discovery with Eureka, because there's a really great functionality of Spring Cloud Gateway. If you're using the service registry client, Spring Cloud Gateway is able to automatically create routes for all the microservices that are connected to that service registry. And last but not least, and that's the most important one, is the gateway here. So that gateway dependency. And now, for example, if you're on start.spring.io and see, okay, what is added here before you download it, you can just click the Explore, and there you can see all the dependencies that we added. And yeah, it's also, for example, great if you want to upgrade to a newer version, to go there and see then, for example, which Spring Cloud version is compatible to which Spring Boot version. So it's always a good idea to go to start.spring.io. And now we want to download it. I will do that on my other screen, just unpack that gateway and put it in our application. Okay, let's go back to the code. As you can see, here it is. And what we will do now is first add a name here, because that's always makes sense. So the application name. And then, as I mentioned, there's a functionality with the service discovery, the automatically service discovery, where all the roads of the services that are available in the Eureka, in our case, will be, the routes will be created for it. The command for that, or the configuration, is Spring Cloud Gateway discovery. So that's the command, and with that, every of our microservices is reachable via the gateway if we call the gateway and just add the name after that. And then we can call every of our microservices through the gateway, and also configure specific stuff like for some circuit breaker and that stuff for it. So that's really yeah, great way to add an easy way to add a gateway you can control. And that's really it. So now it's possible to just call every microservice and through the gateway and configure stuff without, yeah, in, let's say 5 minutes. So yeah, there's a lot of functionality available for you, and you can also build your own filters. You can do everything. You can change the requests, OAuth, as I mentioned. Yeah. So just have a look at it. It's really great. And one additional note, it's not only for Spring applications. So you can use any application, because it's just using HTTP requests and configure those or modify those. You can use any other language you want to use with it. Okay. Okay, with the API gateway in place, it's now time for our next challenge and the monitoring. And distributed systems like, for example, microservices, they have really a need for monitoring, they have for a DevOps culture, because it's the deployment is really complex. Also, the rapid application deployment, because without that, microservice doesn't really have that much benefits. The technical benefits of, for example, resilience and all this stuff is nice to have, but the biggest benefit is that those the fast feedback loops you need to reduce risk. And for that, one also big problem for microservices is our distributed is monitoring. And with that, sorry, I just got a pull up here. Debugging is a big problem, and for that we need a monitoring, and for that we have a distributed tracing. And Spring Cloud Sleuth is a library that supports OpenZipkin compatible systems directly. And in our example, here in the code example, we are sending them to VMware Tensor Observability by Wavefront. So that's an observability solution, but you can, for example, also use Jaeger. And as mentioned, you just have to add with every other library, you just have to add the distributed tracing library, so the Spring Cloud Sleuth, and that's it. And as you see, there's not much room left in that picture here. And the last thing I did here in my example, and you can have a look at it, is that I added or I implemented the shipping serving using service using Spring Cloud Stream, and that's a framework for building highly scalable event-driven microservice connected with our shared messaging broker to communicate with the order service. And I also implemented the business logic via functions. And just 1 second, if you have a look at that, you can see how that looks. So it's really, it's really like you have that function, you get an order as an input, and here is the definition of an output. And then here, in this example, the business logic is really easy. It doesn't really make sense in a real production application, because it's just a timeout. So the order will be sent to the shipping service. Then there will be a configurable timeout, and after that, the status update will be sent that the order will be delivered. But you can see the style, so it's really easy, and also the configuration of that. In this case, RabbitMQ is also really easy, because you just say, okay, that's my topic or channel is the input, and then also the same definition for the output, and that's it. Okay. For streaming data and the functions I showed you. And with that, our Spring Cloud architecture application is complete. So you can see all the building blocks here. And as I mentioned, the code is available for everything. And just one note here is I think the most famous microservices, libraries, patterns, functionality in the past was the Netflix OSS stack. But most of the projects they are in maintenance mode, and with that also the Spring Cloud projects for that. And in this case, for example, for the circuit breaker, Hystrix is in maintenance mode, and another solution is the resilience for J, which we use instead of Ribbon, Spring Cloud Load Balancer, and for the application gateway, instead of Stool, Spring Cloud Gateway. And the maintenance mode doesn't not include Eureka. This is why I used it for that sample project. And yeah, the problem now with that architecture is there are several components like the Eureka registry, the config server, for example, that has to be installed or available. And it's also painful to troubleshoot application issues. And yeah, for that, there are platforms available, like, for example, here, Azure Spring Cloud. And at Spring 1, we introduced, together with Microsoft, enterprise tier with even more components of the VMware Tensor portfolio. And for example, it's really easy to deploy the application to that, your microservice applications. All that config server service registry is already available there. And also that what I mentioned, automatic binding of stuff. So environment variables to your application. So you don't have to configure those server Eureka server IPs and that stuff. Okay, so we have, as far as I know, 10 minutes left. If you have any questions, you can ask them. If not, I will continue. So my presentation here. And yeah, another solution is the Tensor Application Service or Cloud Foundry. That also has the functionality of automatic binding, and those products I showed you with config server, Eureka, already available. So it's really easy to get started. And we are currently working on the same experience on Kubernetes, on any Kubernetes. It's called Tensor Application Platform, which was also announced at Spring 1. And yeah, the second beta now at VMware World, which is currently so we can also have a look at that. So, and the benefit of those is that they have are really high abstractions. So the developers don't have to care whether that's Kubernetes or how to deploy the application. No. And yeah, the deployment, for example, Azure Spring Cloud takes around 45 minutes if you first deploy your application. It's just because all that the full platform will be built for you. And on the Tensor Application Service, because that's already available, the platform is deployment is 10 minutes with creating all the services you need. And yeah, on Kubernetes, that's a little bit a different story because on Kubernetes, yeah, we some of the functionalities we need are already available on Kubernetes. And for sure, Kubernetes is the new infrastructure abstraction standard available and will be there in the next few years. And because of that, I would say all Java frameworks are adding support for it and adding functionality for it. And in our case, since Spring Boot 2.3, we have the cloud native build pack support. So to be able to directly out of Spring build a container image with best practices in mind of your application and push it to a registry. So as you can see, the command is really easy: Spring Boot build image. And then the build pack will detect, okay, whether you are using Maven or Gradle or which components or for example, a Dynatrace, what you are using. And then they are building a container image out of that source code. And nowadays, with the latest version, also pushing them automatically, for example, to a registry. And also that graceful shutdown support is available and Kubernetes liveness readiness probes. And yeah, regarding that, things Kubernetes provides is, for example, as you know, maybe they have services and they also have config map and secret. So the config server and the Eureka is not required anymore. And with the Spring Cloud Kubernetes library, the big benefit is that those are supported. So you don't have to change the code, you just have to add another dependency. And then the Kubernetes service construct will be used. and also the config server. And one last note here, as you maybe know, we have that client-side load balancing, for example, and yeah, for sure the Kate services, if you call a Kate service, you get that load balancing out of the box, but in general, it's not that major than, for example, the Spring Cloud load balancer, and it doesn't have round robin or whatever. So it's like, for example, if you call the same service several times, it could be that all the requests go to the same instance. And for example, if you then want to do something like blue-green deployment, stuff like that, that doesn't work with a Kate service. So with that, it sometimes makes sense to still use the Spring Cloud components, also if some of the functionality is available on the platform. Yeah.
Sorry, Timo, you must come to an end. We already have the next speaker here. Yeah,
that's fine. Perfect. Yeah, so as I mentioned, everything I showed you is available on GitHub, and I can, or I will just put that in the chat. Have a look at it. Also, the slides are available there, but I think they will be also yeah, put by JCON on the website. Okay. Perfect. Yeah. So thank you very much. I hope you enjoyed my session, and yeah, have a lot of fun at the rest of the day sessions here at JCON.